Since a hair is just about the finest fibre you can see with the naked eye, I thought, well, let's start there. Here's a 100 micron human hair, so 10 of these lying side by side will measure a millimetre. This is how that single human hair appears under the scanning electron microscope, with the colour added from a light micrograph. I'm now adding images of 3 erythrocytes to remind us how small they are. So now this single hair will be split into divisions, the ultimate demonstration of split ends. The 3 erythrocytes are still visible in position. And I will take this central example and will subdivide that again into 10. This strand is now 100 times smaller than the width of the hair. We can now increase the magnification and move in closer. The erythrocyte becomes more prominent on this scale, and alongside we can now perceive some smaller features I've colorized. Note that the strand on which they're situated has itself been split into 10. This is where we can encounter bacteria. And what have we here? First, our streptococci. Not all species are pathogenic. Some are harnessed to process yogurt. Next to them are bacilli, which grow end to end, like carriages in a train. Some species create cheese. The curved flagellated bacterium is Vibrio cholerae, the causative organism of cholera. And these are staphylococci, staphs. They normally occur as harmless commensals, but of course they can cause anything from carbuncles to septicemia. We can now increase the magnification until the field is dominated by these staphylococci. They occur widely in nature and are abundant on human skin, but look closer. The last splitting into 10 takes us down to 1,000th of the width of the hair and to the realm of the coronavirus. Here they are, minuscule rounded bodies, each 1,000th the width of the human hair. They now appear as large as the width of the hair with which we began. And if you want to see the ultimate germ, the smallest we know, then here it is, the virus MS2. It's approximately as big as a prion. These tiny agents are too small to contain any genetic material. They cause diseases like bovine spongiform encephalopathy, mad cow disease, variant Creutzfeldt-Jakob disease, and Gerstmann-Strauss-Lachenka syndrome. I'm sorry, I'm just showing off there. But these little things are so small they're about 100 atoms wide. These virions, seen on a monitor, are about 1 million times larger than life.